Thank you, and once again, it's a privilege to be here in Barcelona, and it's a privilege to be linked to this global conference and to MIS dental implant system. What we will present to you today will not be the beautiful clinical images that you just observed from Dr. Ignacio and his team, but we will try to convey to you science. We will try to convey to you the results of our investigations trying to understand the biology behind the V3 system. It is clear that for many years in implant dentistry, different companies have tried to improve their designs in order to achieve better biology in regards to the heart and the soft tissues. And we have lived in these 20 years important concepts as the differences between a tissue level or a bone level implant, the difference between external and internal connection, the difference between parallel walls or conical implants. And we have studied, of course, the histology around these different designs. But so far, the differences have been minimal in terms of how tissues surround these different implant designs. Of course, the implant is not only important in how the heart and soft tissues get around, but also the implant to abutment connections and also the transmucosal components. And of course, we can agree today that concepts such as the platform switch allows horizontal distance and thickening of the soft tissues compared to other concepts where the abutment may be wider than the implant diameter itself. And clearly, when we have done these histological studies, I think it's important that you understand what outcomes have we measured. And we have measured, of course, the degree of osseointegration, which is, of course, the quality of the bone-to-implant surface. We have also looked, and this is crucial, as Dr. Ignacio exposed before, to the maintenance of bone crestal levels, that is the relationship between the bone crest to the implant to abutment connection. And clearly, the soft tissues. The soft tissues both in terms of the height, that is the combination of the epithelium and the connective tissue up to the first implant to bone contact, and of course, the thickness of the soft tissues. We have not only looked at different implant designs, but we have also looked at the impact of the different surgical approaches, surgical protocols. And of course, we have placed a lot of importance on immediate implants. This is a very attractive protocol for patients and also for all of us. But we need to understand what is the impact, the histological impact of immediately placing an implant on the crestal bone remodeling and the crestal bone physiology that occurs. We have also looked at different protocols in order to avoid or in order to increase the vascularity of the bone and the impact of these surgical approaches. And clearly, looking at different surgical protocols, when we have done the histological studies, the outcomes were similar. We again looked at the degree of osseointegration that is normally measured in percentage bone-to-implant contact. We have looked at bone crestal levels that, as you will see, we have to look at them both vertically and horizontally. And we have looked again at the height and the width of the soft tissues. So this is what we have attempted now with a very innovative implant design, the V3 concept. We have, again, tried to understand what it means to have this coronal triangle, which is, of course, the main innovation of this system, that otherwise has an internal connection and a conical implant design. When looking at the histological outcomes of this concept, again, we have looked at these different outcome parameters that I would like to present to you. So the objective of our investigation has been to look at the impact of this coronal innovation of this implant design on the bone, on the soft tissues, on the volume, and also what happens if we combine this implant system with different surgical approaches, that is, placing this implant in a heel ridge or placing this implant immediately upon dental extraction. So we are going to set up our presentation, where I will present first the experimental design, and I will present the histological outcomes, and then Dr. Ignacio Sanz will present to you the volumetric outcomes. I think it's important for you to realize that the implant that we use for the study is not exactly the implant that you place in your patients. We used a prototype during the development stage of this implant design. So you have to look at the outcomes also in regards to the prototype that we use. And as you can see, one of the things that we use when we compared the control implant, which is the conical MIS implant, versus the B3 prototype, where we have the coronal third with a triangular innovation, we utilize exactly the same abutments, and here it is clearly the abutment is wider than the profile of the implant. But the same abutment was used for the experimental and the control. When you look, or when we compare the prototype that we utilized with the actual V3 that you use in your patients, you can see the difference. Also, you can see the prototype we used had an internal hexagon, while the implant that you use has the typical internal connection. Also, you see that the shaving of the coronal part was more accentuated in the prototype that we use than in the implant that is available commercially. So let me share with you the experimental design. We used 9 Beagle dogs. One of them was used as a pilot, but then the study was comprised with the 8 dogs, and we used 2 time points, 4 weeks early healing and 12 weeks late healing. So basically, at T1, we did the extractions. We waited 10 weeks for the crest to heal, and then we placed implants in healed ridges, and at the same time, we waited 8 weeks, and then we placed implants immediately. We waited 4 more weeks, and then we did the specimen collection. I think it's important for you to understand the experimental model if I explain to you a little bit of Beagle Dog Anatomy. You see, the Beagle Dogs, they have 1 very big molar and then 4 premolars, being P1 a very small premolar, and then P2 and P3 2 rooted 1 cusp premolars. So what we did in T1 was to extract half of the molar, half of the P2 and P1. So we wanted to have an ridge in the mesial part, a ridge in the more distal part. So this is the clinical images, and you can see here the big molar, and you can see here the small premolar. So we basically did the hemisections of P2 and M1. We extracted these portions, and as you can see, we left the distal cusp of P2, and therefore we have one distal edentulous ridge and one mesial edentulous ridge. This is the situation that we waited 8 weeks, and at 8 weeks we had a heel reached, both mesial and distally, and we have teeth that we are going now to extract and place implants immediately. So we placed delayed implants in the distal, in the mesial, and we extracted the mesial roots of P3 and P4, and we placed immediate implants in both sockets. Of course, we randomized for experimental and control, and here you have all the dogs, and here you have right and left mandible, and here you have the sites that we used. PM2 and M1 are the delayed implant sites, and PM3 and PM4 are the immediate implant sites. So these are the healed ridges. As you can see, this is the mesial heel ridge, this is the distal healed ridge, and this is the time of implant placement. We have just extracted the mesial roots of both P3 and P4, and we are going to use those sockets to place the immediate implants. So you see the implant placed in the heel ridge and the implant placed in the immediate implants sites. And here you have a closer view of the experimental implant, the V3, placed in heel ridge, and the control implant placed in a healed ridge. And here you have the same, but in the immediate implant sites. You have here the experimental, and you have here the control. This is the suturing, and of course we allow to heal up to. This is important to understand that we placed implants very carefully in order to have the shoulder at the level of the crest in the delayed implant sites, and in the immediate implants, it was the level of the buccal plate that we used as the landmark to place our implants. Clinically, we also measured these parameters because depending on the site that we are going to place our implants, you will see that we may get different results in terms of bone width and bone volume. So, of course, we measured the whole width of the crest in both the P2 and M1, which are the delayed implant sites. And we also measured, of course, the vestibular wall width, which is the distance between the buccal crest and the extent of the ridge in both the delayed implant sites. And we basically did the same in the immediate implants, but also in the immediate implants, we measured, of course, the gap depth and gap width in order to understand what is the impact of the gap on top of the gap that the test implant has due to its coronal design. So with these measurements, we could understand the impact of the site that we were going to place our implants. And it is clear that when we compared in the delayed implants, the mesial and the distal site, we have wider crests in the implant site. We had, of course, the vestibular buccal bone width is higher in the distal side, and very similar the distance between the lingual side to the implant. So this is important when we analyze the results, because since these differences are statistically significant, we need also to analyze the impact of the site when we analyze the differences between the experimental and the control implants. When we analyze in the immediate implant sites the implant of the gap, you can see differences between the sites were not very important. Mostly what was important for us was in terms of the horizontal measurements that you see. Of course, the distal premolar has a bigger gap. This also happens in humans, depending on the tooth that you are placing your immediate implant. But you can see in terms of the lingual, there are no differences. In terms of the socle dimensions, we have bigger sockets buccolingually in the second, in the fourth premolar, similar mesiodistal differences. So we will see, with this information you have now from the experimental design, let's look at the results from the histology. So let's look at the histological outcomes. We are going to look at the histological outcomes basically at 3 levels. We are going to look the vertical measurements, and the vertical measurements, you understand, is from the implant to abutment, from the shoulder of the implant to the first bone-to-implant contact, and another distance is from the shoulder to the bone crest, to the most coronal peak of the bone crest. You can see when we compare the differences between experimental and control, and between delayed and implant sites, you can see that there is always less vertical resorption in the V3 compared to the control, although these differences were not statistically significant. Here you can see 2 samples. This is the V3, this is the buccal side. You can identify the coronal difference in the design. This is the control, and this is the experimental. You see, this is the peak of the bone, this is the peak of the bone in relationship to this abutment that, as you can see, goes over the diameter of the implant. When we look at the distance between the shoulder to the first bone-to-implant contact, you see here we have the experimental, we have the control. Basically, there are less vertical resorption in the experimental, but differences in the vertical dimension are not statistically significant. And of course, you have here all the situations depending on the site. You can see that in this situation, the vertical loss is minimal. You see in the test site there is 0. Here in the PM2 also is 0.5. Only in the molar, that you understand is the wider and probably will need more time to reach the maturity of the bone, we have close to 1 millimeter in both sides. So in most of the sites, the vertical distance is about 0.5 millimeters. Here is the same situation with the shoulder to the first bone-to-implant contact. Again, you have here an experimental, a control site, very similar results in both levels. Again, here you have another situation where we have the shoulder with the wider abutment to the first bone-to-implant contact. Here is the control, the shoulder to the first bone-to-implant contact. So this is basically the summary of the vertical measurements to the first bone-to-implant contact, which is normally, as you can see, about 1 millimeter. But of course, when we look at the soft tissues, normally the soft tissues translate the results from the vertical measurements. So depending on how the bone-to-implant contact is in regards to the shoulder, we will have longer or shorter biological width. And here, of course, when we have measured the biological width, the results go in parallel to the vertical measurements. We have a very well-established biological width already in the first time that we have measured at 4 weeks. The whole biological width measuring between 2 and 3 millimeters has been established. This is the epithelium, this is the connective tissue, and of course the combination of these 2.5 plus 2 will be the biological width. It is very well established in the literature, and I think we have several publications on this, that in the immediate implant situation, you always get about 1 millimeter more or biological width than when you place your implants delayed. And at T12, you can see that we have the mature biological width very well established, and you can see that very little difference in regards to both implant systems and in regards to immediate or delayed. And here you have some histological slides where you can see the very well-established soft tissues already at T4 that remain well established at T12. And you can see how we measure, of course, from the gingival margin to the first contact, and then we divided what it is epithelium and what it is connective tissue contact. But probably the most important of the measurements that we are going to deliver to you are the horizontal measurements, because this new implant design was meant to augment the amount of bone buccally to the implant. And we have done measurements at the crest, 1 millimeter, 2 millimeters, 3 millimeters, and 4 millimeters below the crest. So you can see whether the impact occurs more coronally or whether the impact occurs more apically. And here you have 2 clear examples of this V3 specimen, where we have quite an important width, and we have this control specimen that we also have a certain width, and therefore we are going to measure what happens here, 1, 2, 3, and 5 millimeters below. First, let's look at what happens in the delayed implant sites. And in the delayed implant sites, you can see at the different levels that at 0 level, that is at the peak, we have already some width in the experimentals. We normally don't have anything in the controls. And you can see how the width is always higher at C1, 2, and 3, almost up to 5, which is 5 millimeters below the crest. So the first 3, 4 millimeters to the crest are clearly wider in the experimental implants. Here, you see again, this is the M1, which is the wider of all the sites. This is the molar, and we also have, again, the situation. In this situation, since the crest is very wide to start, we only have differences in the first part, because immediately, of course, the bone becomes very white. When we look at the immediate, here we see even clearer the differences. Here we see that the advantage of the V3 occurs in all the dimensions that we have measured, from the most coronal to the most apical. And of course, here you see what I believe is a beautiful histological slide of the V3 with the wide amount of bone and the control situation. And you see that almost on the most coronal, we rarely have any bone in the control side. And of course, I would like to see the same histology if we had, as we should, a platform-switched situation in regards to the implant to abutment connection, that unfortunately we didn't have it in this situation. Again, here you see in the immediate implants, this is PM4 site, how differences are clear and statistically significant even, but you have to realize that in animal studies, because of animal welfare, we use a limited number of dogs, and therefore sample size is always small. But in spite of that, you can see here again, this is the V3 situation, and the width of the bone in comparison with the control site. And here you have some examples. This is T4 at 4 weeks. This is T12, 6 weeks. You see this is the V3 versus the control. This is the control versus the V3. And you can appreciate by yourself the differences in width. This is, again, an immediate site, also a T4 and a T12. And again, you see this is the control site. This is the experimental site at 12 weeks. And at 4 weeks already, you can see a less mature bone, but it's already filling the gap in these immediate implant sites. And you see the impact of the shaving of the coronal third of the implant. Similarly, you see at T12, this is the experimental, this is the control, this is the experimental, this is the control. And we could go on and on with all the different specimens that we have produced. This is again an immediate, this is the T12 experimental, this is the control, this is the control, and this is the experimental. So I think the histological outcomes are very clear, but clearly the histology only provides us with a section in the center of the implant. Of course, it's very relevant because it's the buccolingual section that is of interest to us, but let us share with you the volumetric outcomes, and I give the podium to my colleague Ignacio Sanz.
Good morning, dear colleagues. Thank you, Mariano, for the opportunity to share with you today the volumetric outcomes. It's a pleasure, and I want to thank MIS as well for their support. And I think today when we evaluate the outcomes of implant designs, obviously the histology is still going to be the landmark and the gold standard that we use, but today we cannot look away from the new developments that science, that technology offers us. And obviously with histology, we do have some limitations. We're only looking at the real center of the implant. We're looking at sections that have 30 to 40 microns of width. So if we could have the opportunity to look at a wider area of the implant, we perhaps could assess as well what is the bone volume and what are the impacts on the soft tissue of these different implant designs. So today, as I wanted to share with you, we do have the opportunity of checking with this type of images. These are micro-CTs. And micro-CTs are a way of evaluating sections. This is a non-invasive way of evaluating the histological sections where we have very high exposure and very high detail. You can appreciate here the dentinal tubules. You can appreciate here the pulp, the ligament for the periodontal space. And we can check as well here in these other slides the bone anatomy very well. So this gives us the opportunity to analyze not only in a particular section, but to analyze a wider area. And we've done this through a good collaboration with the University of Santiago de Compostela in Lugo, with Maria Pernouy and Fernando Muñoz, and we want to give them credit for that. Obviously, with this type of images, we are able to do a 3D reconstruction, and the 3D construction, as you will see, gives us the opportunity of having a better look at the histological sections of the implants. And you can see as we move from buccal to lingual, not only we have the opportunity of checking the buccal aspects, but you can see here as we move towards the distal, the tooth, and how we can scroll through the images to better analyze these mesial bone and distal bone. Not only that, we have the opportunity as well of rotating these 3D reconstructions and checking from up above what is the bone width on the buccal. You can very well appreciate here the implant design and the thread pattern. But the question remains of whether this is just a nice image that we can enjoy our view and our sight with, or whether we can actually get valuable objective data from these measurements, as we always discuss. So the answer is that yes, we can obviously get reliable data with this type of reconstructions. And what we do is we get the image from the micro CT, and we select a region of interest, and that region of interest is in the middle of the implant. It involves the buccal and the lingual, as well as the mesial and the distal. So I'm just going to quickly share with you a video where you can see how we upload the image in the software, and we try to have the implant straight, and then we select a region of interest. And this region of interest is going to be, as I discussed before, involving both the mesial and distal and the buccal and lingual. So here, what we want to assess is a wider region of the sample, and basically here our two objectives are going to be to analyze the bone-to-implant contact. When we analyze bone-to-implant contact in the past, we used to have only one histologic slide. Now we have the opportunity of analyzing this through this technology, where you can see we're looking at 360 degrees around an implant. We select a volume and interest, and now the software, through a series of measurements where we play with the grayscale, will indicate us what is bone and what is titanium and what is air. So now we have the opportunity of analyzing in these regions and in these sections whether we have titanium, bone, or air. So as I was explaining today, we have this information in the literature that tells us the micro-CT measurements to analyze the bone-to-implant contact are more reliable. Obviously, we found no difference in the site. We do have the same surface technology, so we didn't expect any differences. We analyzed the bone volume, the relationship of the bone volume to the tissue volume, and I will go further in detail in the next slides. When we looked at the bone volume, tissue volume, this is not really an area that we are interested. We would like, if possible, to analyze the area that's more towards the buccal aspect, and that's the area that is more important to us. So what we did is we selected a smaller region of interest, and that region of interest was focused on the buccal aspect, as you can see here. And once again, allow me to show you the video. And here we're basically, again, selecting a region of interest that's going to be 150 cubic millimeters, that's going to be around the buccal aspect, and we'll center that on the buccal aspect, and we'll have that in the center of the mesiodistal image as well. So you can see here the type of area that we select, and once we lock that, we can go ahead and analyze the 3D reconstructions, and you'll see here in the 3D image how now we have a smaller section, as you can appreciate here. That's the buccal aspect and half of the implant that we are evaluating, and please appreciate that we are as well selecting part of the mesial and distal aspect of these implants. So once again, we run the software, we select these areas, and now we play with the grayscales to tell the software where is bone, what is air, and what is titanium. Now, the interesting part of this study is that now we're going to analyze how much volume of bone do we have on the buccal aspect, not on one section, but on a wider aspect of these implants. So I'm going to show you some of the cuts of the implants that we evaluated, but I think what's more relevant is the numbers, the histograms. Here in yellow, we have the percentage of bone that we had for the test and for the control, the percentage of air that we had, and the percentage of titanium. So roughly, we had about 25% of bone for both the test and the control, same percentage of air, and obviously less percentage of titanium for the test when we compared with the control. We had 14 roughly compared to 12 in the test. These differences only for the titanium reach significance. We obviously have less titanium on the tests, and we had exactly the same patterns for the other delayed side and for the PM3 and the PM4. These are the immediate sides, and the only difference is that we had slightly less percentage of bone in the immediate sides when we compare to the delayed sides. Once again, reaching significance only for titanium. So if we would analyze the absolute values for cubic millimeters in terms of the different implant designs, those values really mimic the ones that we just saw in terms of percentages. Similar values for PM1 and PM2, and then when we look at the immediate sides, we really have, once again, the same values. So we've analyzed the histological sections, where we really look at a very narrow slide that it's important for us. We've analyzed as well a greater volume and a greater area. Now, perhaps the more important information for us to translate into the clinics would be, how does this translate into the soft tissues? So at the end of the day, we have a very comprehensive image of how this implant design is working. So for that, what we took is impressions of these dogs, and you have here the baseline impression, and here you have the post-implant insertion impression. This is at 12 weeks after. Here you can actually appreciate the healing abutments of these implants, and what we do to analyze the differences is that we use this MOP software, and what we tell this software is common points that the software can use to align and to match these two surfaces. So you see, we select the cuspids, and now we're going towards the molars to tell the software common references. So the software, first of all, can go ahead and perform a rough fit, and once the rough fit has been performed, we can continue to tell the software other common references, so the software can better align and can perform a fine fit. So then, after all, we can analyze what are the differences in the soft tissue. So after that's been done, and we have the matching of the two surfaces, we're going to go ahead and look at this blue slice, and I'm going to go ahead and hide the preoperative view, so we're only seeing now the postoperative view. Now you can see that we will scroll this blue image so that we can have cutting these two implants evenly. These are two immediate implants that you can see. Here are the ones on the healed ridge, and then we're scrolling this slide to have both the right and the left side with the slide being cut evenly. And now you can see here very well the healing abutments. Now we'll focus on this one on the left side of the dog. You can appreciate very well the healing abutment. You can appreciate the fossa of the premolar. And once we have this matching, we can go ahead and perform the measurements to understand what are the changes that occur not only on the bone, but in the soft tissue level as well. So here we can go ahead and perform these measurements. So for the measurements, what we actually did is on the immediate sides, here is the contour. In yellow, you have the preoperative contour, and in green, you have the postoperative contour. And what we went ahead is we draw a longitudinal line here, and then after that, we measured the crestal width at the level of the gingival margin, and after that, we measured at 2, 4, and 6 millimeters below the gingival margin. So we did a very similar design for the delayed sides, where you can see we've measured at the H0, H2, H4, and H6. This is not somewhere that we've just come up with. This is something that we've published both in a Pontic study that was published in 2016 and around implants that was published around 2015 with a very similar measurement design, where we have a longitudinal slide and we measure at the level of the gingival margin and at different levels below. So let me share with you the values of these horizontal measurements. Always looking at the sides, we cannot compare different sides, so that's why we analyze side by side. And when we look at these measurements, please notice that we have positive values and we have negative values. We're looking at H0, H2, H4, and H6, and we're looking at the test and at the control implant designs. And you can see that we have very similar patterns in PM2 and in M1, and both similar patterns, both at the test and at the control. But what is interesting to notice is that here in the delayed sites, we're having a gain in width. And this is something that one would expect if we think at the design that we have. We're placing a crestal or slightly lingual incision, and then we're moving that tissue towards the buccal. So if you think about it, this type of design, one would expect that you get some gain in width of tissue. Now, when we look at the immediate sites, you can notice that there is a difference. We're actually having loss both in PM3 and in PM4, very similar values both for PM3 and PM4, and no differences for the test and for the control implant. Now, we are not testing whether delayed or immediate implant is better. That was not the goal of this study. When we look at the delayed sites, we're comparing the crestal width after tooth extraction to the one that we have after implant insertion, while when we look at these sites, we're looking at the contour of the ridge while the tooth is present and the contour of the ridge after the tooth has been extracted. So these are two different models, but for us the most important part was to check whether there were any differences between the test and the control implants. So the conclusion was that we found no differences, and I think I'll hand to Professor Sanz the conclusions so we can wrap it up.
So let's wrap it up. The results from these investigations, and as you can see, by using the V3 implant, we have seen that we have a minimal vertical bone crest resorption. And of course, this also has to be looked at considering that the implant to abutment connection was not ideal in the sense that the abutment was wider than the implant itself. When we look at our main outcome measurement, that is the outcome that is related to the change in the design of the implant, is where we can see the significance of the differences. And here we can see that the coronal bone from the level of the crest up to the 4th millimeter in the immediate implants and up to the 3rd millimeter in the delayed implants was significantly wider comparing the tests and the controls. Go. We see that, of course, we are using the same implant, the same surface, the same drilling system. We shouldn't expect differences in osseointegration, and of course, we had a similar degree of osseointegration. And also, we are placing our implants at bone level. So we are getting thicker bone crest in front of the implant shoulder, but the soft tissue contours are not affected by what it is inside of the bone crest itself. We are hoping that by attaining thicker bone crest in the coronal level, that bone will be maintained over long-term better. So this is why we didn't see differences in the soft tissue contours, although you saw the impact of the surgical approach by comparing the delayed to the immediate implants. So with this, I hope, or we hope, Ignacio and myself, that you had a glimpse on the biology of the V3 implant system, and we are certain, after looking at all the histological sections, that this implant design, it is favorable in terms of the idea on what it was designed, which was to increase the coronal crestal bone. Thank you very much.